Question 10. Here we go. So I changed the subject question. Just checking I can move it. That's fine. Change the subject. We're going to change it to B. Okay, to B or not to B? So it's going to be, oh, maybe highlight that instead. It's going to be B. Why that's jumping. So yeah, we're looking to get B. Now, there's a few things to think about when we're doing change the subject. Just zoom out a tiny bit as well. A few things to think about when we're doing change the subject. We're always thinking about opposites. Okay, and we want to move something from one side of an equation to the other, we always do the opposite. Okay, so if on one side of the equation there's a times, on the other it will become a divide. If it's adding, on the other side we'll take away. If we're taking away, we'll be adding. And if we're dividing, multiply. The ones that are a little bit trickier is if we've got a square term. So if we've got an x squared, that'll become a square root. It doesn't have to just be x, it could be a whole bracket as well. Okay, likewise, if something's being cubed, it'll be a cube root. So that was meant to be used. Still 2 in there. And that's a 3. Okay, so we're thinking about doing the opposites. Okay, to move something over, do the opposite. And as I said before, the best way to describe this is because we're balancing an equation. All right, so if I say I've got 2x is equal to 5, okay, and I want to make x the subject, okay, how do I get rid of a times by 2 or a divide by 2? Now, what I'm actually doing is dividing both sides of the equation. Sorry, dividing it by 2, sorry. I'm dividing both sides by 2. Okay, because to get rid of a times 2, I divide by 2. So these cancel out, and then the 2's left on that side. But instead of doing the times, like this, it's dividing. Okay, so that's the kind of mechanics of it. Effectively, all you need to think on is, if I change sides, it changes operation. It does the opposite of the operation. Okay, so that's one thing to think about. The other thing is also, why don't you try some numbers, okay, see if it makes sense, right? So what if I said that t was, let's try t is 4, okay, and let's go for b is 5. So 4 squared is 16, so 4 squared is 16, plus 4 times 5, 20, so that's 36. Let's take c as 6, okay? 36 divided by 6 would give us 6, so then f is equal to 6, okay? So there's some nice numbers that are making sense, okay? Now ideally, actually, these numbers would all be different, just as a better way of checking, is less likely. Yeah, less, it's just a better check, okay? But that'll do, okay? If it's a complicated equation, it's hard to come up with stuff, so that'll work, okay? So I know that, yep, t squared plus 4b divided by c gives me f. So 4 squared plus 4 times 5 divided by 6 gives me 6. Okay. So what I can do at the end is plug these numbers back in and see if the equation still makes sense. Okay. So opposite operations, and let's do a little check. Okay. That's something that people don't often think about. Okay. The next thing is, when we do this, we're really trying to move things that are furthest away from what we're trying to find the subject of. Okay. So for example, we've got 4b. Now 4 times b, 4 is right next to b, so that'll be the last thing we're going to move. Okay. So I suppose people will be thinking to themselves, well, what do I do first? Do I do divide by c, or do I square root, or what we do? I would rewrite this. I would think on this as f is equal to t squared plus 4b. It's basically in a bracket, isn't it? Divided by c. Okay, we have to do this top operation first before we divide by c. Okay. The other way of thinking on it is that actually that equation is f is equal to t squared divided by c plus 4b divided by c. Okay, so that's why it's important to remember the bracket, right? Because everything has been divided by c. So the first thing we should do is definitely get rid of the c. So how do we get rid of divide by c? Well, we times by c. So we should end up with f times c is equal to t squared plus 4b. How do we get 4b on its own? Well, we want to move the t squared over. So this is effectively plus t squared, isn't it? So to move it over, we do the opposite of so before we were doing the opposite of divide, which was timesing. And now we're doing the opposite of adding, which is taking away. Okay, so we'll get FC, which is already there. In fact, sorry, I'll rewrite that just FC like this. Take away t squared, and that's equal to 4b. Now it's very important we write it like this. The f and the c are, technically it's like this. They're in a bracket together, aren't they? We're doing the f times the c, then taking away t squared. Okay. So be careful when you write this. Okay. Then we want to move the 4 over. So how do we move the 4 over? Well, we're doing 4 times. To move it over, we'll do the opposite. It'll be divide. So that's going to give us fc minus t squared, and the whole thing is divided by 4. Okay, because again, this operation would be done first. This operation would be done together. You do t squared. So you do f times c, and you would take away. So you do f times c, then you would take away t squared. Okay, you wouldn't do f times c, take away t, then square it all. Okay, so that's why it's important to make sure all of this is divided by 4. Okay, and that should give us b. Now again, what we just check to make sure if that makes sense. So f times c, that's 6 times 6, that's 36. Take away our t squared, that was 4, so that's take away 16 divided by 4. So what does this give us then? 36 take away 16 gives us 20. 20 divided by 4 gives us 5. Okay, so I would say as a check, that's good. Now, I'm not saying that's passable, pen's gone crazy. I'm not saying that's a perfect check. Okay, that sometimes I could still give you a false negative effectively. Okay, but I'd be thinking if that was working, that's a very good indication I've not made a silly mistake somewhere. Okay, so not the most difficult question in the world, but it does make you think. Okay, you've got to think about doing the opposite of the operation. Now the tricky bit here, I suppose, would be people would think, well, to undo a t squared, I would do the square root. Okay, that's maybe the mistake people would make. But actually, no. To move it over, that's effectively an add t squared, isn't it? It's 4b plus t squared. Yeah. So to get rid of the plus t squared, we take away t squared. That's probably the only thing people might find confusing. If we're trying to make t the subject, then at this point we would take away 4b and then square root the whole lot. Okay. And yeah, at this point as well, remembering that the whole lot gets divided by 4, some people might just divide part of it by 4. Okay, so we're looking at doing opposite operations. So remember what your operations are. People seem to forget about cube roots and square roots. Do a little check to make sure it's sensible. And imagine you're going to work in from furthest away or the least connected items to what you're trying to change the subject to. So we're trying to change from B, so I'm trying to think things furthest away. So I can look at that instantly and think, well, 4 is last, So what's the kind of furthest away operation from that? Okay. So if you're struggling with them, practice makes perfect. They're all you will definitely get it. There's a little bit of an art to it, I suppose. Honestly, practice just makes perfect with them. And after a while, it really will become second nature. Don't be put off. It just requires a little bit of practice. Okay. Question 11. Express this as a single fraction in its simplest form. And again, I'm looking at these questions thinking these are almost exactly the same as the other papers. There's very little difference in some of the standard questions. It is incredibly similar there. Okay, so we're trying to take away fractions. What did I say at the very beginning about fractions? They need to have a common denominator if we're going to add or take them away. Okay, so in this case, what I said before was doing smile and cross, wasn't it? I'd said that if you wanted to do, say, a half, take away or add, an eighth, you could just multiply these two numbers together and work in 16ths. You could do that, okay? But you could also just say, well, I know that if I times this fraction by 4, it'll go into eighths, and I'll end up with 4 eighths, and just keep this one the same. Okay, so you could just multiply one fraction out. So for this one, I'm thinking let's just do that. Okay, so instead of timesing the a's together, let's just say, well, as a common denominator, let's just take a squared. So what that means is I need to times the top and bottom of this fraction by a. That becomes a, that becomes a squared. Okay, so now I've got 3 minus 2a divided by a squared. I think that's pretty decent. I don't think I can take that any further. Let me just have a think. I probably should look further ahead when I'm doing these, but sometimes I just kind of jump in and think, well, is that it? And actually, yeah, that is the answer. Simple as that. There's nothing much else you can do with it. The only, so yeah, I've still got a wee bit of time in the video. The only thing what I was saying you could have done with smile and cross. Okay, so you could have said, if we do smile and cross, we're going to end up with 3 over a squared minus 2 over a. So if we do our cross like that, we're going to get a cubed and a cubed. Okay. And then this is going to be 3a, 3 times a, and then minus 2a squared. Okay. So we can put them together. 3a minus 2a squared divided by a cubed. On the top, we can take a out as a common factor, so it's going to be a 3 minus 2a divided by a cubed, and then all you're doing is taking away a, and you get the same answer. Okay, so a lot of folk might have done it this way, which seems a bit more complicated, but that's the standard smile and cross method. Okay, to make sure you get that common denominator. But both methods are absolutely valid. Okay, so not a lot going for 2 marks. You're getting your mark for your common denominator, and then a mark for your final answer. Okay, so common denominator, final answer. And I actually forgot, sorry, just up here. Let's just check the marking scheme for that. Yeah, C, T, and 4. So you're getting a mark for moving C over, mark for moving T over, and then a mark for moving 4 over. Okay, so that's question 10 and question 11. So yeah, don't get confused about your fractions. Just apply the exact same rules as before. Like I said here, I was cheating a wee bit, or not cheating, but I could spot the common denominator. So I just had the times top and bottom by a. But smile and across would be absolutely fine. I've just not drawn my cross in there. Smile and cross would be absolutely fine. Okay, good stuff.